So our next speaker is Kremitzki. He is an agriculture and biology engineer, and he's also a Debian developer. He is also an active project contributor of the FreeCAD project that he will be talking to us now in the afternoon. He is also about to embark on his master's degree next year. So help me welcome him, everyone.
Thank you. Thank you. Hello, everyone. So my name is Kremitzki, as she mentioned. I'm here today to talk about FreeCAD and Ubuntu. And I just wanted to thank you all for coming and also give a quick thanks to everyone who was involved with bringing us together today. So the structure of my talk, I'm going to kind of just start quickly with some background and then talk about the details of FreeCAD before I get into sort of packaging details. And so I guess just first, I'm not going to assume anyone actually knows what CAD is, so just the definition of that is computer-aided design. And so FreeCAD is actually not only a CAD program, you might more accurately call it a CAX program because it also pulls computers into helping with manufacturing and engineering. And so we have a sort of a detailed history wiki page if anyone is interested in sort of the background of the project, because it has been around for quite some time. As I have here, you see in 2001, the project was sort of initially announced, although that wasn't the initial release date. And the project founder was Jürgen Riegel, and he also had Werner Meyer working with him at the time. Currently, Jürgen is not really participating in the project anymore, and so Werner is sort of the project lead. One of the other main developers, Jörg van Hav, he joined the project around 2008. And so he is an architect, and he was able to bring that experience to bear towards the project, and so that's one of the main areas that he works on. One other sort of important developer who has recently joined the project is a person by the name of Jung Lei, who goes by Real Thunder on the forums. And I just wanted to mention him because I'm going to be talking about some of his efforts later on. He's working on some sort of major overhauls to the internals of FreeCAD. And so doing that, there's some major difficulties, and we're going to talk about some of the ways that he's dealing with that. So just a quick introduction, a little bit of details about myself. Some of this has already kind of been mentioned. Biosystems engineer, I choose that just because biological and agricultural engineering is way too much of a mouthful. And then I am a Debian developer, which is not just someone who works on the project, but is basically the D is capitalized because that means that I'm a full project member. And I contribute to Ubuntu, but I don't really have any formal structure with the project in the same way. And just to unwind and enjoy myself, every now and then I get a chance to play fighting games on Linux, and I dabble in a couple other types of games, but that's probably 80% of what I do. And so I want to talk a little bit about why people are interested in FreeCAD and why I chose it as well. This first bullet, I wasn't really sure how to phrase it because I kind of didn't want to name any names, and it's sort of a general thing, but the incumbents in CAD software, they have a very, very strong incumbency, and so they're not really pressured to make changes that people really appreciate. More often, the changes that they make drive people towards FreeCAD, and so recognizing the issues with their behavior is one reason why I am interested in the FreeCAD project. And this is not just true. I specifically said incumbents because it's not just CAD software. CAD is also part of Windows entrenchment as well. Besides gaming, those are sort of two major areas: advanced engineering applications and then games. And then obviously this last bullet point, I dropped that not to dazzle people with dollar signs, but just to kind of indicate the significance of CAD software in our society. It underlies a lot of pretty major things, especially even going forward. I think it's just going to increase. And so I mentioned this earlier, just sort of the rough structure of my talk. I'm going to give sort of a tour of FreeCAD where I talk about the workbenches, which is sort of the main way that the code is structured in the program. And then I'm also going to talk about what I term the cast of characters, which is dependencies and optional integrations, you might say. But because there's so many of them and you have different programming languages, different governance structures and stuff like that, it's not necessarily just a dependency, or a dependency that is not quite enough of a word for it. And then also, I'm going to touch a little bit on some news in the project, as well as sort of where we're going. And then hopefully we'll have a little bit of time for some questions and answers at the end there. And so some of the things that I was hoping that the audience would take from this talk, I say here rally for FreeCAD, but it's really kind of goes towards my own background in the project. When I first started, I wasn't really capable of doing very much, but I recognized that there were some, I guess you could say minutia or, busy work that some of the more capable people in the project were involved with. And by looking and trying to find those things that I could help with, I was able to free up time for them so that they could work on things that were maybe more impactful that I couldn't work on. And so really, any little bit of effort that people try to contribute can have that effect. And even if you aren't necessarily able to make deep underlying changes like Real Thunder is, for example, you can still free up someone else who could free up someone else who could free up something he's working on. And besides that, I just wanted to share sort of some of the things that I've learned packaging FreeCAD. And it's not quite a reference because it's just too much that I could really fit into this talk. But at the very least, I kind of name drop some things that people can go and look up later and just talk about some of the relationships between the different packaging tools and the sort of hierarchy or trade-offs that you have by choosing them. And so one of the first things, like I mentioned, is the workbench structure, which is it's very central to FreeCAD. There's several, I guess, decisions or advantages for doing this. One of them is just that, FreeCAD is a pretty big program, and if you had to compile it every single time you wanted to make a change, not only would that just take a lot of time, but it's not very user-friendly. And so we can sort of have loadable code that third-party developers can distribute easily, and people can just copy the files into their computer, and it can load the code dynamically. And one of the other big advantages is that FreeCAD's scope is ridiculous. And so if it had to load all the code for all possible functionality as soon as it started, it would just take too long. And this way you can just kind of load the code as needed. And one of the other things is that the workbench structure, there's a lot of dynamic modification of FreeCAD, so that, for example, it's possible that if you load one workbench and then another and then go back, you may not have deterministic behavior. Or I guess you might say it's not necessarily idempotent to load a workbench. And so I guess I wanted to talk a little bit about some of the details on this slide, because this is diagrammed specifically for the part workbench, which is one of the more fundamental workbenches in FreeCAD. And so at the very bottom there's a bar that says OpenCascade technology, which is basically the central library for FreeCAD, which I'll touch on a little bit later. But part is sort of just a wrapper on top of it, which among other things provides just a very basic Python API to OpenCascade's C++ code. And then the sort of primitives that it allows people to interact with, that can then be used in other workbenches. And so above that, you have a line of different workbenches: part design, sketcher, draft, arc, or arch for architecture. And then above that, you have sort of the actual types of objects that are involved. So you might have like a solid, for example, a part. So let's say you just create a cube. Simple enough. A sketch, you may have a wire that would indicate sort of the outline of the base of that cube. And then also there's sort of the solid on the outside, which indicates the data interchange. So we can take something that wasn't made in FreeCAD and start modifying it as well. And so I mentioned workbenches, but sort of a higher level concept is the idea of workflows. And I kind of talked a little bit about that with how, for example, you can use like the wire around sketch. A wire sketch can then be used to, let's say, extrude a cube or something like that. And so one of the sort of ultimate workbenches, and I mean that in the sense that it's one of the final things that you do, is the FEM workbench. And I'm gonna let's see. So FEM is just it's finite element method. Not really going to go into too much detail on that because it's a pretty deep topic, but basically it's a way to take sort of strange shapes and very difficult math and break it into, let's say, triangles and problems that are in the domain of linear algebra as compared to like partial differential equations or something. And so one other thing that this slide has is it's a bit of a preview of some of the components I'm going to talk about later with Gmesh, NetGen down there. Those are two solvers, or rather those are two meshers, excuse me. Two meshers that are used, like I mentioned, to break down these strange shapes into more manageable things like triangles. And then to the right of that is the solvers. And so those are things that actually take sort of the engineering constraints. So let's say, for example, the behavior of a material under load or something like that. And it goes and does the math on those triangles to see what the outcome will be. And so the FIM workbench, like I mentioned, it's a good example of a workflow where you would produce a shape or something like that in another workbench, and then you would load it, you would load the FIM workbench, and then go in there and do your analysis. And there's also options for post-processing. And so some of that actually is possible within FreeCAD, but you can also just send it off to something like ParaView or a renderer, for example. And so now I'm going to kind of go through sort of a tour of various major workbenches, drafts. This one it's very similar to, let's say, AutoCAD, for example, in that, you know, if you're used to working just on a 2D grid and just drawing shapes directly, you can do that. But FreeCAD is a 3D CAD, and so you aren't necessarily restricted to actually only working in the plane, as you can see in the shape down there. And so this is not actually a workbench, but this is kind of a preview. This is sort of a type of modeling, I guess you could say. There's two main paradigms in FreeCAD. This is sort of the more basic one, and if you kind of look at the bottom of this diagram, on the left, for example, you see that we have 3 cylinders, and then those are joined in an operation union so that we have all the components and all of the pieces. And then on the right, we have a cube and a sphere, and we have the common or intersection operation, and then we take those two results and then combine them with a cut to end up with our final product. The only problem with this is that it's very, very manual. You know, it's rather than, you know, something that you can program, you have to go in and place the pieces and put together the sort of the operations that relate them to the end product. And so, for example, if you change your mind and say you wanted to, instead of that particular cube, you wanted maybe one that's a little bigger, it isn't necessarily easy to go in and make that change. You have to sort of redo the process. And like I mentioned, there's 2 main paradigms. I just described the CSG one, and the next one is the parametric approach, which is really what FreeCAD is for, but it's not required to actually use it in that way. And so in terms of parametric design, we start with the Sketcher workbench, which is it's restricted to working in a plane. And so in this picture, we have various colored objects. You can see there's some of them are green, some of them are red, some of them are blue. And so we are working with the geometry, which is the green stuff. Then there are constraints. So for example, you can see there's like an arc constraint on the outside left, and there are also some, you know, dimensional constraints on the inside that say that, you know, these pieces need to be so far apart from each other. And then we have construction geometry in blue, which is just a way of having a reference without actually having something that is actually a physical component or a real component in the sketch. And so, like I mentioned, parametric design starts from the sketch. And so in this case, I'm starting just with a trapezoid. And so this is going to showcase, just through a few quick screenshots, the behavior of the part design workbench, which is sort of the main parametric design one. And so we start here, like I said, with a trapezoid, which is fully constrained. And so there's geometry, which is fully specified as far as where it should be, rather than something that could be moved within the plane, for example, or stretched and made larger. And so with that sketch, we then do an extrusion operation where we take the trapezoid and just push it in some direction for some length. and then we have another sketch here. And in this case, the sketch is actually on top of what we were just looking at, and it's just a simple square that we're going to use as the base for the operation, and we're actually doing a cut operation, and then also a mirror, so that we're taking those two pieces out from the top. And so kind of going back to the sketch, what we're looking at here, if I were to go in that sketch and change one of those, let's say, distance constraints, I could, it's not automatic, but this whole thing would recalculate. And so the difficulty is that right now in FreeCAD, there's a possibility of instability for that recalculation. And so it's one of the main, I guess, problems facing the project, because when someone makes a complicated model, they don't want to, if they want to be able to interact with parametrically, they don't want to have to go in and redo it because something broke. And so that problem, it's called the topological naming problem, and that is sort of the main thing that Real Thunder has been working on. But the difficulty is that it's a very intensive change. And so one of the other, I guess, main shortcomings to FreeCAD is that we don't actually have a native assembly workbench. And so once you're done with part design and you've made, let's say, this screw, you're going to want to define its relationships to other parts. So for example, this washer, we wouldn't want it to be on the other side of the nut, and we wouldn't want it to be, beyond the screw or something like that. And so I put that asterisk there because there's I'm not sure the exact count, but there is at least, for example, an Assembly 4 workbench, an Assembly 3 workbench, Assembly 2, Assembly 2 Plus. And these are all just people trying to come up with implementations that the project will ultimately adapt. And so one other thing, Real Thunder is also working on, his is the Assembly 3 workbench. And so it's possible with maybe the next release, which I'm going to get to at the end, that we may integrate that. And we're considering that once the assembly situation and the topological naming problem situation are resolved, that we may decide to finally have a 1.0 release. And so once you come up with a part, it may just be a model of a part that's already off the shelf, but you may want to have someone actually manufacture it, and that person may be used to working with paper drawings. It's not really uncommon. And so it's possible to take that part. This is the finished part with a few more operations added to it, and then produce this technical drawing which shows the dimensions of it, and you can have different views and things like that, so that you can communicate what you think is important for the person to actually make that piece. So this is the FEM workbench that I mentioned earlier. And so this is just a classic example of beam bending, where you have just some sort of piece of material and there's a load attached to it, and you want to see how it bends. And so this is sort of a fundamental thing in the mechanics of materials. And so in this picture, I also wanted to mention that we have the original beam, and then we have sort of a colored beam, which is it's deflected. And so this is actually what I mentioned earlier, where there's post-processing options inside FreeCAD, and this is using VTK, which I'm going to get to in just a moment. One of the other interesting applications, engineering applications with FreeCAD is CFD, or computational fluid dynamics. And so this screenshot is someone's project where they just did a very simple case of 2D flow, and you can see sort of the streamlines where along the line the fluid is moving at a particular rate. And so under the hood, this uses a project called OpenFoam, and there's some interesting implications there because FreeCAD is LGPL licensed and OpenFoam is GPL licensed. And so even though we have a workbench that uses OpenFoam, we can't actually distribute it directly. And so we have to use the binaries provided by the package. So I mentioned manufacturing of parts, and so this is one of the things I think is most interesting in terms of potential for FreeCAD. You see here we have a plastic brick, and there are sort of green and red lines indicating the path that would be taken by the hot end of a 3D printer, for example. And I think that this screenshot is not quite the path that would be required to make this, but it's something else. But it's just a very relatable example of a plastic brick. And so one thing that would be interesting about this is that you can create a model in FreeCAD, and you can go in and you can produce this. This is called G-code, by the way, which is the machine code used by these devices that describe the actual path that it needs to take. And so it's possible, once you have this G-code, to do something kind of like, file print, let's say, where you send it off to a 3D printer, and then, if it's set up, you just go pick up your part at some point later on. And so I mentioned 3D printing, but that was actually the path workbench, which is more general than that. It can be used for what we might call additive and subtractive manufacturing. And so what we have here is just a simulation of the results of the end of a tool following the path that was produced by that G-code. And so we can see basically the thing getting carved out here. And so this is a very interesting aspect, because the title of this slide is CNC milling, but it's more general than that. People, for example, use laser cutters or hot wire devices to cut pieces of foam. So I know one person uses that to make prototypes for boats. And so we're getting now to the section of the talk where we talk about sort of the components or the cast of characters. And there's a little quote here, just a kind of woe is me type of thing, where FreeCAD, we never met a dependency it didn't like. And so people find something interesting, they want to see if it works, and if it does, it kind of just sticks around. And so it's not necessarily something that you can deal with, or that you can control. You just kind of have to deal with. And so I guess the most fundamental aspect of FreeCAD is the application framework that we're using, which is Qt. And so this is what is responsible for us being a cross-platform application. Part of the project's goal is that we can run on everything, although in practice that's limited by developer bandwidth. And so when you have people who are capable of working on CAD, you don't really want to have them be messing on, let's say, widgets on different platforms. And so it's nice that Qt is able to take care of a lot of these things for us, but it would be better sometimes, possibly, if people had even more, let's say, wish list, if FreeCAD had some KDE components, for example. And so the next major component of FreeCAD is OpenCascade, and that's some people call the CAD kernel, or it's the library that is responsible for those operations that I mentioned earlier, like cuts and unions, and even for creating the primitives like the cubes and the spheres and cylinders and so forth. And so OpenCascade is kind of an interesting project. It's definitely a big contributor to the complexity and difficulties of FreeCAD, because part of the reason, at least, is that it's been around for a while. And so since they were solving problems that were solved by later standards of C++, they have their own implementations. And so, for example, like a smart pointer. And so that makes it, it's sort of got all this legacy, I wouldn't necessarily say baggage, but it makes it somewhat more difficult to contribute. And so one thing that would be nice in terms of a potential future is, let's say, for example, with OpenCascade, a part of it is responsible for the interchange of data and file format support. And so there's sort of a security surface there. And so, just for example, if we were able to take parts of OpenCascade and re-implement it and, rewrite it in Rust, not to really suggest that, but something like that could potentially have beneficial impacts on the health of the project and CAD and open source in general. And so it originally started as a commercial project, but they relicensed it, and so that's sort of how FreeCAD actually was born. You notice that the relicense was in 1999, and the project started in 2001. And just another sort of signal of, I guess, the nature of the project is that the only bindings that they actually provide, and which they also require bug reports to be reproducible with, is in Tcl. And so there are Python bindings, but it's a third-party project. There's a PyOCCT, I should say, in addition to FreeCAD's Python bindings. And so one of the next major components for FreeCAD is Coin3D, which also was, I guess, released to community, if you will, from a commercial project. And it's a scene graph library, which it's kind of a complicated topic, but I guess a scene graph is a way of dealing with all the things that you were looking at in a way that doesn't require you to draw all of them, even if you're not looking at them, for example. And so it is based on OpenGPL, and so it is what is responsible for taking care of that aspect of FreeCAD for us, essentially. And it's an implementation of the Open Inventor API, which was, I think SGI was behind, and so part of the difficulty, the reason Coin was released to community was that SGI opened up Open Inventor, and all of a sudden the commercial aspect, the landscape changed. And one thing that's interesting about this, I mentioned FreeCAD is LGPL licensed, and Coin3D was relicensed from GPL in 2011. And so I haven't done the digging on this, but I just wonder if from the 2001 to 2011 period, if FreeCAD was technically potentially having license issues by being a GPL plus LGPL. Or rather, I guess it was FreeCAD at that point probably was just GPL. And here's one of the other components of FreeCAD, VTK, which is the visualization toolkit. And so we use that for some post-processing within FreeCAD. And so, for example, I mentioned that in the picture earlier, we had a beam, and then we saw the deflected beam. And the beam is the only real object. The deflected beam is sort of just a visualization. And so in this case, for example, we have some house type of structure with some load on the top. And realistically, if this house was deformed in this way, it would explode or something. And so there's a scale factor so that you can exaggerate the impacts of the loading situation of your part. And so this is a screenshot from Gmesh, which is one of the main meshing tools that FreeCAD uses, in addition to NetGen. And so whenever we have sort of those engineering analysis type programs, we rely on these as sort of a first step. And I mentioned OpenFOAM earlier. It's the general category of solvers. This is a screenshot from Calculix, which is what we use for example, the screenshot of the deflected beam was produced with Calculix. And so this screenshot is interesting. It's showing the eigenmodes of this compressor. And so that's basically the behavior of the part under vibration, or and so one thing that's you might not think that this is necessarily something you have to worry about, but it's actually quite a bit of a problem if you have a part that you were not expecting to vibrate and then it starts vibrating. And a really famous example of this is the Tacoma Narrows Bridge. If anyone has not heard of that, I would suggest going on YouTube and pulling up the video. Okay, so now we're to the packaging tools aspect of the talk. And so, like I mentioned, this is largely beyond the scope of the project, but just kind of, or the scope of the talk, but kind of starting from the beginning. When you're building FreeCAD, for example, on your own machine, you would issue like a CMake command with some flags set, and then like a make command to actually do the building. And so depackage build package is a way to take the packaged version of a software and then use the, let's say, installed dependencies on your machine to just run through the steps of packaging. And so if you were wanting to produce a FreeCAD package, this would be one of the first steps that you would do. The downside to that, though, is that you actually have to have the packages installed. And if you install all the packages for all the things you ever would want to build, you can have a pretty messy system. And so it's nice to use some isolation. And there's many options for that. The next item mentioned here, debuild or debuild, is just the first command in addition to lentian, which is another, I guess, foundational tool in the Debian and Ubuntu ecosystem. It's a linter for Debian packages. And so let's say, for example, you have there's all sorts of problems that are checked by this tool, and it'll let you know what the health, or the health of your package is. And so I mentioned earlier that the problem with depackage build package is that you have to install all the dependencies. So for FreeCAD, that's a lot. And so if you aren't using them, you may not want to keep them around. And so sbuild is sort of the next level of tool that you would use when you want to have a clean build. And it uses troots, or CH roots, which is just a way of kind of having all the base packages of a Debian Ubuntu system sort of isolated at a file system level. And so a couple of the packaging QA tools that I use in FreeCAD. Auto package test is just a way of taking the binary packages produced by the build and then using the tests that are in the source package and making sure that they work together. And so one example of a problem that this could catch is if you have a situation where the test only passes when it's actually inside of the build versus the produced binaries. And so another level of I guess, quality that is something that I'm interested in kind of for the whole FreeCAD ecosystem is repro test. And so depending upon how you build things, for example, there can be things like dates embedded inside the files. And so if you were to build it once and then again, you would not actually have the same checksum for the files. And so you don't necessarily know, for example, if something else has changed. And repro test is a way of going in and doing things that could potentially cause differences in the produced files and identifying them. And so if you can pass repro test, it's a really nice property of the package to be reproducible. And so because there's a whole ecosystem of dependencies with FreeCAD, if you make a change at sort of a low level, you may need to do a lot of builds of other packages using that new package. And so RAT, or rebuild all the things, is another thing that's pretty useful if you're dealing with these types of problems. And so I mentioned how dpackage build package, you sort of build on your system, and even sbuild does the same. And so the problem with that is that if you want to continue to use your machine, for example, it can be sort of a pain. And so it's nice to just have a remote build server, and Launchpad is a really nice way of doing that. And there are several different ways that you can interact with Launchpad. You can actually just upload binary packages. So for example, if I had something produced by dpackage build package, which could have some undesired change because of the dirty build environment, I could still send that on up. And so it's accepted, but not necessarily ideal. And so instead, Launchpad uses something called recipes, which, so for example, a very simple recipe would be FreeCAD, the Git repository for FreeCAD, and then the examples are actually removed from Debian because of DFSG reasons. And so we can just kind of take those removed examples and just put them back in Ubuntu. And so with recipes, you still need to specify the actual Git repository. And so for example, you're going to need to have that Git repository on Launchpad. But then if you have to maintain the one that you're actually working in and the one that's being used for your build, that can be an issue. You would want to have some sort of automatic updating process. And so I'm going to do a bit of a no-no here, which is sort of a bug report by talk. But with Launchpad, you can go in and point you can point a repo on Launchpad to something on Salsa, which is Debian's GitLab repository. The only difficulty with this is that it's only allowed to have one. And so, for example, if someone else has already gone in and made a automatic mirror of a package on Salsa, then you cannot do it yourself. And this wouldn't necessarily be a problem, except they can update the URL that is pointed to. And so if you were to just go ahead and assume that you can use it, you could potentially expose yourself to a security issue. And so, yeah, just maybe a little bit of change would be required there to make it a little easier, because this is actually something that specifically has happened to me, where someone else has kind of already taken a mirrored package. And so I have the choice, which I won't take, of using that. And so I just kind of have to manually deal with that. But luckily, it's a minor dependency, and so it's not something I have to update very often. And so as a Debian developer, I am kind of starting from the bottom in terms of providing debs for people who use them because people like them. But I also want to have things in a PPA because people use that as well. And even the same goes for snaps, which I'm going to get to in a moment. The only thing, though, is that PPAs are fundamentally unsuitable for a couple of reasons. And I've actually had breakdowns happen. So FreeCAD, for example, is in an ecosystem of advanced applications. KeyCAD is one of them. And there's actually a dependency in KeyCAD on FreeCAD. And so those two PPAs had their own versions of OpenCascade. And that resulted in those PPAs not being, it's not possible to use both of them at the same time on the same machine. And it's really, really not desirable because people use them in conjunction. And so it's more common in that case. It's also the case sometimes that people use QGIS, which is a Geospatial Information Systems program, on the same machine as FreeCAD. And I've had a problem before where they updated the version of GDAL, which is a Geospatial Data Abstraction Library, on their PPA, and all of a sudden co-installability was broken. And so as much as I like debs and PPAs and things like that, you kind of have to cover all of your bases. And so I am not personally maintaining the FreeCAD Snap, but I do know that in addition to the main one, Real Thunder is actually using snaps as well. And part of the reason for that is that with the PPAs, for example, we have the FreeCAD PPA and then a daily PPA. And this is something that I could fix, but they're not co-installable. And so I basically go in there and set FreeCAD to a FreeCAD daily, and that way we have separate paths. But this is not really correct. And so with snaps, you get rid of that co-installability problem. And so one other thing is that Real Thunder's changes are very fundamental. And so he's making these adaptions that can't be distributed, or it requires recompilation, I should say. And so it's a kind of a pain. He can't just, put up a release file or something like that of like Python Workbench, for example. And so because he's making very invasive changes, I guess you could say, he's taking advantage of the channel support in Snap, which is, more of an appropriate way of handling the FreeCAD daily sort of division. And so he's actually able to get people to get sort of the get head version of his changes in a very, very easy way that doesn't require any building on his own machine or anything like that. And so even though I am not involved with them, it's kind of apparent that, we do need them as well. And so I mentioned earlier the topological naming problem, TNP, is sort of one of the elephant in the room with FreeCAD, and I just wanted to kind of explain that briefly. And so this is sort of an illustration of how the problem can arise. And so if you look at the shape on the bottom, you've got faces, and if you want to refer to a face, you might give it a name, like let's say face 1, face 2, and so forth. And so in order to assign names to all the faces of a shape, you have to have some algorithm for doing it. And you want it to be predictable, because in the example of this shape, let's say, for example, the bottom shape, let's say what the top shape is resting on is like face N. If I were to go in there and cut a groove in between the left and the right side, it would produce two different faces. And so if that top shape was attached to face N, we would want face N to be what's on the left as compared to on the right. And the difficulty with this is that it's actually possible to produce, let's say if instead of cutting cleanly to the side of that top shape, I were to go diagonally or something, that actually should not work at that point. So you can't, you have to be very, very careful with the algorithm for naming. And so it's a very difficult problem. That's what Real Thunder has actually been able to largely solve. The stability, it is still possible, like I mentioned, to break the model, but you don't want it to break when it shouldn't, on accident or something. And so this is an example of what people are using to get around the TNP situation right now. So I mentioned that in that case, if we had the top shape attached to a face N, then if that face were to be recalculated and split into two faces, it's not clear which one it should attach to. And so instead, let's say, for example, the height of that bottom shape was defined by some parameter h, and then we could have a datum plane, which are these sort of yellow objects. And the datum plane, for example, would be only dependent on that parameter h, rather than the name of a face. The problem with this is it's just more work. And so even though it is, when you model in this way, it is extremely robust, it's not always what you want to do. And so we should allow people to use the program in not just the most correct way. And so FreeCAD 1.0 potentially is on the horizon with some of the changes that have been made recently, which is really incredible. The TNP fix it's been a while, because last I saw, it's something like 70 to 100,000 lines of code changed. And so that has to be broken into many, many, sort of atomic changes rather than a single change set. And so it's something that's taken quite a time and caused a bit of division, but it seems like things may be kind of coming back together soon. But the problem is this sort of invites a terrible, terrible amount of bike shedding because, people, if we're going to change our version from, currently 0.20 to 1.0, should we actually even use semantic versioning? Like, is the advantage of that worth it for us? Some people are wanting to do calendar versioning. And there's lots of different, discussions going on about this. But it's nice because we're actually getting to the point where we could make a change based on this discussion rather than just spinning our wheels. And so if anyone is interested, we are planning a FreeCAD meetup on the Friday before FOSDEM. And in addition to the potential for in-person collaboration there, it's also possible to just keep track of project news. We have a blog which has kind of just recently been created, and so some people are running that. And another very interesting piece of news with FreeCAD, in case anyone hasn't heard, is we actually formed a nonprofit organization in Belgium. It's Association sans but lucratif, to be specific. And so it's been a really interesting change because formalizing governance, we kind of learn as we go and find, things that we need to potentially change. But the big takeaway from us having formed this is that it is now easier for us to receive money, and there's more of an incentive due to tax purposes. But spending it remains really difficult. And even before this project association, that was sort of the main difficulty. It's not only spending it just in terms of ways that are above board, but also ways that, people won't have problems with in the project. And so we're coming to the end of the talk now, and so I just wanted to kind of drop a few references here as far as how people can potentially help. We have an entire wiki page which is dedicated to getting people onboarded to the project. And we also have a LibrePay account which is shared among several developers. And so I'd say that's probably the preferable way if anyone were wanting to do financial assistance. And then I also have my own Patreon as well. But I would say the main thing is that, like I mentioned, the point of this talk is to kind of rally people towards FreeCAD so that even if you are only able to do something that might seem small, it actually could have a pretty significant impact. All right, so that's my talk. Thank you, everyone.
Thank you, Kate. Okay, we have our volunteers ready to bring the mic around if you have a question. Okay.
Hello.
Hello.
Has the 3D printing revolution changed your kind of approach to FreeCAD?
Well, it's definitely, that's where the people are. And so I don't know if it's necessarily changed so much, but, we kind of, so for example, I mentioned how, incumbent CAD programs do things that tend to drive people towards us. We recognize that 3D printing is the same way. And so we kind of have to be ready to receive people when that is the interest that brings them to us. But I would say it's probably increased the entire ecosystem is growing, and so as a result, we've also had growth because of that.
I just haven't found a great open source solution. I mean, I often find myself using OpenCascade, where I'd rather use FreeCAD, but it's just so quickly convenient.
Mm-hmm. Yeah, so I meant to repeat the question the last time, but so you just mentioned OpenCascade or OpenSCAD. I'm not sure which one, but so that's sort of a more programmable CAD option where it's directly scripting, and so with FreeCAD, this is something that's also possible. There's actually a Python interpreter in the program that as you click a button, for example, the corresponding Python command is shown in the interpreter, but the interpreter is not shown by default. And so it's also possible to record macros, essentially, of the Python commands that are being ran as you do things, and then replay them, or even just inspect what commands were being used in a particular workflow. But yeah, I'm glad you mentioned that, because FreeCAD is not the only CAD option in open source. There are others, and it's really a rising tide lifting all boats type of situation where, for example, there is an OpenCascade workbench in FreeCAD. And so people who like that sort of modeling approach can use that workbench to kind of pull the program into a workflow and come up with something that works for them.
Thanks, and thanks for all your work.
Thanks.
Okay. Do we have more questions for Kurt? One more here.
Nice.
I have more of a packaging question. You mentioned something about the snap being very customized. What exactly?
Well, so yeah, I think that's not. It's not that the snap is necessarily more customized, but that the changes that he is making introduce the potential risk of someone opening a file and that file being corrupted, for example. And so it's something where these changes, they need to be tested, but it has to be done in a way that is very easy to, let's say, switch from the stable branch to the tip of his code. And it has to be, like I mentioned, that's probably one of the main concerns with the adoption of his changes, is that we never want to have someone already have a FreeCAD file that they produced and then open it and it somehow either stop working completely or actually break the file if they were to save it. And so that's something that we had a major overhaul of the part design workbench in 0.17, and that was sort of something that happened occasionally for people who are like following the tip of FreeCAD. And so we want to be very careful to avoid that ever happening, because otherwise if people become burned by FreeCAD, it's kind of hard to get them back.
Okay, we have one more. We have enough time.
Just for interest, how long is your Snapcraft YAML? Or
How long has the Snapcraft been?
the definition file for the?
Well, so I'm not, I've only kind of dabbled in the actual maintenance of the Snap, so I can't answer, I'm sorry.
Okay, do you have, okay, right.
We're actually checked. Tutorials for FreeCAD, are they
Yeah.
being rehauled or something? Because they seem very like, now you need to draw a wall, but they don't really say how to draw a wall and things like that.
So I didn't catch the last part of that.
Oh, the tutorials are pretty relaxed
Right.
in telling you what to do.
Oh yeah, yeah. It's something I didn't mention, but I originally found FreeCAD around 2012, and so it's been really interesting seeing the huge changes. And that's one aspect where the importance of tutorials and showing people how to actually get onboarded is important.
Okay. Do we see any other question? We are good. Okay.
All right.
So thank you, Kate, again. Yeah, we have.
Thank you.